Using this is the combined overcurrent and artful relay trainer. Using this trainer, we are going to perform 3 experiments. First experiment is to plot the IDMT characteristics of the numerical overcurrent relay, and then we are going to perform the experiment on definite or instantaneous mode setting of numerical overcurrent relay. Then the third experiment is to plot the IDMT characteristics of the numerical arc pole overcurrent relay. So here this is having two relays. First one is numerical overcurrent relay and another one is numerical arc pole overcurrent relay. So this is the relay and we are going to put different setting for different experiment here, and this is the single phase AC input panel. So from here we are going to give the AC supply to the current injector as well as AC supply to the this combined overcurrent or an arc-fault relay panel. So this is the variable voltage and current injector panel, and this is the overcurrent measurement and elapsed time counter. So here whatever the current injected from here will be measured in this panel. It will show the current and this will show the trip time, and this is the terminals of this relay. So for different experiment we are going to connect in the different location on this panel. So let's proceed to the experiments. In this combined overcurrent and arc-fault relay trainer, we are going to perform 3 experiments. First experiment is to plot the inverse definite minimum time characteristics of the numerical overcurrent relay. The wiring connection is made as per the wiring sequence given in the lab manual. After the wiring connection, we are going to turn on this 2 MCB. This 2 MCB will give supply to the relay and as well as the relay circuit. So here this is the relay, and this relay is RII Pro 3EI. So in order to put the relay setting, first we have to press enter key, then we have to go to the protection. After that we have to press enter key, and we will give the relay setting as per the setting sequence given in the manual. So this is the setting sequence and we have already given. Then after giving the relay sequence, in order to come out we have to press enter. Then we have to reset it before performing the experiment. So in order to reset it, we have to press 5 seconds at this enter. Now we are going to give the current setting in the relay. So this experiment is performed for the current input of current plug setting of 0.5. That's why after the calculation it is come out as 2.5 ampere. In order to give the current setting, we have to put this bypass switch to the open position, that is the left hand side. Then we have to push start button and we have to increase this knob, and we have to first put at 2.5. So at 2.5 there will be no tripping. That's why we are going to increase it to again 5. Now it is again increased to 5. Then we have to stop it and we have to reset it. This time counter, we have to reset this time counter, and after that we will close this bypass switch. Then we will put the start push button. Then we are going to take the reading of this time, that is the tripping time. So let's start it. When the tripping occur, this L1 LED will blink continuously. Now it trips the circuit. Now we can see that L1 is continuously lighted. L1 LED is, and the time to trip is 9.95 seconds. So you have to note down this time and you have to calculate the time multiplier setting for this particular experiment. So this is the first observation. In order to take the next observation, you have to press this enter key for 5 seconds, then it will reset. Then you have to put to the open position. Then you have to set the current to 7.5 ampere. Now let's set the current to 7.5 ampere. Now it is 7.55 ampere. So stop it, reset it, and you have to reset this one also. Now it is also reset. Now you have to put this to the close side for this bypass switch. Then you have to push the start button and wait for the L1 to trip. Now for 7.5 ampere of the current setting, it is tripped at 6.4 seconds. From here, what you can see is the relay operating time is decreasing when we increase the full current. Okay, like this you have to take around 7-8x observation and draw the plot for this overcurrent relay. Now we are going to perform the second experiment on this trainer kit. The second experiment is to perform the experiment on definite or instantaneous mode setting of numerical overcurrent relay. The wiring is connected as per the wiring sequence given in the lab manual. Then first we are going to turn on this 4 ampere MCB, and it is the power supply for this relay, and we are going to give the relay setting here. In order to give the relay setting here, we are going to use enter key to go to the protection. Then we are going to edit the settings as per given in the lab manual. So here we have already set these values. Then after completion we have to press enter in order to come out of it, and in order to reset the relay we have to press the enter key for 5 seconds. Okay, and if when we change the value of any parameter, if the password is asked for, in the meantime if password is asked, then we have to press enter key 5 times. Now we are going to set the time, set the current for the relay. So in order to set the current, first we have to turn on this 1.6 ampere MCB. Then we have to push start button, and by using this dimmer we have to set it to the 5 ampere. So in the 5 ampere this circuit won't blow, so we have to set it to 6 ampere, and we have to stop it. and we will reset this, and we will reset the relay also. Then we will push the start button to perform this experiment, and by the meantime we have to close this circuit also. Okay, so let's close it first, and we will push the start button, and we will see when the fall is happened. So fall is happened at 5.05 second. So when the fall is happened, this L1 LED will be lighting for continuously. Okay, so here we can see that for 6 ampere, this is the time taken for the relay to trip. So like this, we have to take the 4-5 observation for 7.5 ampere, for 10 ampere, 12.5 ampere. Now we are going to do the third experiment, that is to plot inverse definite minimum time characteristics for numerical artful overcurrent relay. So first of all, we will turn on this 4 ampere MCB, and it is supplied for the relay, and we are going to put the relay setting here. So in order to put the relay setting, we have to press enter key, then we have to go to the protection part by using this up down key. Then we have to press enter key here, and we will set these values. So in order to set the values, we will use this right key, and whenever we change the value, we have to if the password is asked by the relay, then we will press enter key 5 times, and we have already set these values, and if it is back sign is here, then we will press the enter key, and we will press enter key for 5 seconds to reset it, and it will show L1 and L2. Now we are going to set the current. So in order to set the current, we have to push the we have to first turn on this 1.6 ampere MCB, then we'll push start key, and we will increase the current to 1. So at 1 there won't be no trip, and at 2 also there won't be no trip. So for this relay, at 5 it will trip. Okay, so we have to set at 5 ampere. Then if relay is tripped during this one, we have to stop it, and again we have to start it, and we can set to the any desired value of the current, that is 5, or if we want to take the reading for 6 or 7 ampere, 0.7 or 1 ampere, we have to set it. Okay, then in order to start the counting of the time for this relay, we first reset the relay. We have to reset the relay, then we have to reset this time, and we will put the bypass switch to the close, and we will push the start button. Now this relay is operating for 0.5 ampere, and this LE will blink, and when the trip is happen, this LE will continuously light. Okay, and the time for 0.5 is 9.47 seconds, and we need to take the reading up to 5 observations in order to draw the characteristics.